In lesson 4.4, we are talking about Pascal's triangle and binomial expansion. So let's start with Pascal's triangle. You may have looked at this before. It starts with 1, and then 1, 1, and then 1, 2, 1, and then 1, 3, 3, 1. And so this should be memorized, but really it's not memorization, it's just figuring out the pattern. So we start with a triangle of ones, and then from then on you are adding the two numbers to get the number below it. So I've got 1 plus 1 makes the 2. Then I have 1 plus 2 makes 3, 2 plus 1 makes 3. And there's just a row of ones on the outside. So I've got, the next one would be 1, and then we add those to make 4, add those to make 6, add those to make 4, and then we've got 1 on the outside. And so if you just make a few rows of Pascal's triangle, and we're going to be using this triangle to help us with binomial expansion. All right, that should be enough. So I've got 7 rows there. And the reason I'm saying 7 rows is because this first row counts as row 0. So I've got row 0, row 1, 2, 3, 4, 5, 6, 7. And you can see the row number by the number, the first number after the 1. So here it's just row 1 because there's a 1 after the first one. Then there's a 2, which makes row 2. There's a 3, which makes 3, 4, 5, 6, 7. So that's how you can figure out what row you're on. Now, we use this to expand binomials. So the old way of doing this, we would have to write x plus y 7 times and FOIL each one at a time, which becomes a really lengthy process. But instead, we could use Pascal's triangle and kind of create a shortcut here. So you've got 2 terms, which is why it's called binomial expansion. In the first term, you're going to count down. And the last term, you're going to count up. Okay, so we've got x is our first term, that's going to count down. Y is our second term, which is going to count up. And 7, the exponent, tells us what row to look at. So here I'm looking at row 7 in Pascal's triangle. And so these are the leading coefficients, or not leading, the coefficients of the variables. So what I'm going to do is take row 7 and kind of spread it out, because it's going to be a long answer. So I've got 1, 7, 21. I'm going to run out of room. Okay. So those are the numbers. Then I take x and count down, and it's starting with the highest exponent. So it'll be x to the 7th, x to the 6th, 5th, 4, 3, 2, 1, and then x to the 0, which means there's no x. And then we take the y's and we count up. So counting up from 0. So this will be y to the 0, which means there's no y. Then y to the first, y squared, y cubed, y to the 4th, y to the 5th, y to the 6th, y to the 7th. And that is your answer. So this was much faster than going through writing it 7 times and foiling all 7 binomials. So if you want to check your work, you could go back and FOIL that 7 times if you really want to, if you don't trust me, but that is what you would get. Let's look at number 2. If you want to pause the video and try it on your own, do that now. But if not, the 4 tells me to go to row 4, so I'm going to write down my numbers. And then I've got x as my first term and negative y as my second term. So you got to include the sign with the second term. So I'm going to have x to the 4th because that's the exponent, and then that is going to count down. So no x on the last one. And I've got negative y, that's going to count up. So negative y to the 0, not there. Negative y to the first, negative y squared, negative y cubed, and then negative y to the 4th. And then on this one, we have a little bit more simplifying to do. So I'm going to have x to the 4th. This is going to be minus 4x cubed y. Here the negative will go away, so plus 6x squared y squared. Here the negative stays because it's cubed. So negative 4xy cubed, and here the negative would go away because it's to an even exponent, so plus y to the fourth. So that would be my answer. Let's look at 3. So I've got row 6. So 1, 6, 15, 20, 15, 6, 1. X is my first term, negative 4 is my second term. So I'm going to have x to the 6th, x5, x4, x3, x2, x1, x0, and then negative 4 to the 0, negative 4 to the 1, negative 4 squared, negative 4 to the third, negative 4 to the fourth, negative 4 to the fifth, negative 4 to the sixth. Hopefully you spread it out a little bit better than I did. And then we're going to go through and solve these. So I've got x to the 6th, not solve, but simplify. Negative 4 to the first is just negative 4. And so then we're going to have negative 4 times 6, so negative 24. X to the 5th. I've got negative 4 squared, which is going to be positive 16. And then you multiply the 16 by the 15 in front, and you get positive 240. We've got negative 4 to the third, which is negative 64. And then we're going to multiply that by the 20 in front. So you're going to have negative 1,280. Here we've got negative 4 to the fourth, which is 256 positive. And then you take that times the 15 in front, and you get positive 3,840 x squared. Here we've got negative 4 to the fifth, and then we multiply that by 6, and so that is going to be negative 6,144x. And then you've got 4 to the sixth, which is 4,096, and it's positive because it's the even exponent, which cancels out your negative. So that one's just a little bit different because it had numbers in it this time instead of just a y. On number 4, you've got a mixture of numbers and variables. So we have row 3 because of the 3. So we've got 1, 3, 3, 1. When you look at Pascal's triangle, we've got 3x to the third. Then we're going to have 3x squared, 3x to the first, and then no 3x. Then we're going to have no 2y, 2y to the first, 2y squared, and 2y cubed. And so here, when you do these exponents, you're going to have to distribute in. So you're going to have 3 cubed, which is 27, and then x cubed. Here you're going to have 3 squared and x squared. So that's going to be 9, but there's a 3 in front. So we've got 27, and then you've got a 2. So we've got 54. And then x squared y to the first. All right, here I've got 4y squared and a 3x and a 3. So 3 times 3 is 9 times the 4, so we've got 36. And then x and y squared. And then I've got 2 cubed y cubed, and that is going to be 8y cubed. On 5, same type of problem, only you're going to have a negative as well. So here we're looking at row 4. We take 2x and we count down from the highest exponent 4. We take negative 3y and count up from 0. Usually I don't put it, but I just did it to the 0. So you can either not put that or you can. All right, so we've got 2 to the fourth, which is 16, and then x to the fourth. And anything to the 0 is just 1, so I didn't really need to write that. I've got 2 cubed x cubed, and then negative 3 to the first and y to the first. So we've got 2 cubed, which is 8, and then we have a 4 in front, and we have that 3 in front. And so we're going to have negative 96 x cubed y. Here I've got 2 squared x squared, negative 3 squared y squared. So that would be 6 and a 4 and a positive 9. So you're going to have positive 216 x squared y squared. Here I've got a 2x, a 4, and a negative 3 cubed and a y cubed. So I've got 4 times 2 times negative 27, which is negative 216 again, x, y cubed. And then I've got negative 3 to the fourth, which would be positive 81 y to the fourth. And then our last expansion problem, I've got x squared plus 5 to the fifth. So 5 tells me to look at the fifth row. We're going to have x squared counting down. Five is going to count up. All right, so I've got x squared to the fifth. You multiply exponents when you have that, so I'm going to have x to the 10th. Here I'm going to have 5 and 5, so 25. And we multiply those exponents, x to the 8th. I've got 5 squared and a 10, so 250. And then we multiply those exponents, so x to the 6th. I've got 5 cubed, which is 125, times 10. So that's going to be 1,250, and then x to the fourth. And then I've got 5 to the fourth times another 5. So that will be 3,125 x squared. And then I've got 5 to the fifth again, which would be 3,125.